Okay, so we're going to identify several parts. We're going to identify the vertex, we're going to identify the axis of symmetry, the domain and range, okay, and we're going to identify the zeros if there are any. And to do that, we're going to start by graphing it. So remember, what we did before is we have to find A, we have to find B, and we have to find C. A is the one number that is in front of x squared. In this point, we have -2. B is going to be 4. C is going to be 6, because those are what they associate with. Recall that to find the vertex, you have to do -b over 2 times a, which means x is going to equal -4 over 2 times -2, which gives you 1. So our x value is 1. To find our y value for our vertex, we have to plug this back in. So -2 times 1 squared plus 4 times 1 plus 6. When you plug that into your calculator, you get 8. So that means I have a vertex that is within our table of 1, 8. Now we need to pick values around 1 that are going to be whole numbers. So we have 0, we have -1. Go above that, we got 2 and 3. Those are our whole numbers around that. When we plug 0 in, it's real easy. Your x's will just go away, and you'll be left with 6. If this is symmetrical, that would mean that 2 is also going to be 6. And it is symmetrical because I did pick numbers that were the same distance away from 1. So 0 is 1 unit and 2 is 1 unit. And so there I have that symmetry. If you plug -1 in, we have -2 times -1 squared plus 4 times -1 plus 6. Remember, when you plug numbers in, you need to make sure that you're plugging numbers inside of parentheses. Otherwise, you may screw some things up with negative numbers. But when you plug this in, you'll get 0, which tells me that when I plug 3 in, I'm going to get 0 as well. So we should automatically know that since A is less than 0, that this graph is going to be turned down like this. Turned down for what? And what we're going to do is we're going to go ahead and graph that. So let's draw our lines. Again, it's pretty small, so we can graph it on one. We don't have to change our scale or anything. So our first coordinate was -1, 0. Our second coordinate was 0, 6. Our third coordinate was 1, 8. Our fourth coordinate was 2, 6. And our fifth coordinate was 3, 0. You want to try to sketch it so that it's got some curvature to it. Remember, it's got symmetry. So the first thing we want to identify is our vertex. Our vertex is the turning point, which is 1, 8. Our axis of symmetry is again our x coordinate of that vertex. We know it's turning down, so that means our vertex is a max. It's a max value because it's going down. So remember again, your line of symmetry is located in between here, where I could fold that over and overlap it. I know I didn't draw a really great curvature on that, and so it doesn't look and appear that it could be folded over, but it can. So there's your symmetry. Your domain is always all real. Know that. Your range is your y values. Now, if you remember, on the one we did before, this thing was turning up. Turning up for what? And so since it was turning up, I would have done that, right? But this time, it's turning down. So since it's going down, we're going to make sure it's less than. It's always equal to. For right now, we're looking at equal to because that dot right there is solid. So it's going to be less than 8 because we know that it's going to go down. So my range is always going to be a value that's lower than 8. And that's what it's trying to tell you. The domain is trying to tell you that you can plug anything in along this value of x. But if you were going to look at the y values, the only thing that you're going to get out is something that is less than or equal to 8. And so that's what that means. Now, how many zeros we have? Or solutions, or roots? Well, zeros, I have 2. And what are they? Well, they're where they're crossing the x-axis, remember. So -1, 0, and 3, 0. So I can write that as the coordinates there, or I can write them as a set of values without those zeros. Okay, we did that pretty quick, but you should remember that every time we're trying to find coordinates, we're plugging our x in and getting our y out. The whole idea of doing this, though, is picking domain or x values that are surrounded by my vertex so that it creates a symmetrical figure that we have here, okay?